Alright, ladies and gentlemen, for number 2, we have that a teacher surveys their students to find out if they have eaten at the local Thai and Indian cafes. The results of the survey are shown in the following Venn diagram. So just so that we understand how Venn diagrams actually work, in this case you have that for the Thai cafe, 10 of them only have eaten at the Thai cafe, while 23, because it includes the 10 and the 13, have eaten at the Thai cafe. So 10 have eaten only at the Thai cafe, and 13 have eaten at both the Thai cafe and the Indian cafe, and 8 have eaten only in the Indian cafe. See? So that is one of the first things we sort of have to point out of how Venn diagrams work. And this 2 out here, what's happening? No, it's not a typo. This 2 is people that have eaten at neither. So they haven't. Okay, they have not eaten at neither the Thai or the Indian cafe. So now that we got that out of the way, this is not that hard of an exercise, but you do need to understand the intuition of the Venn diagram. So for part A, we have to write down the number of students surveyed. So this is pretty much straight to the point. As I mentioned, this is the ones that only ate at the Thai, this is the ones that ate at both, and this is the ones that only ate at the Indian, and these are the ones that ate at neither. And I don't see any other number anywhere, and so all you really have to do for part A is add 10 plus 13 plus 8 plus 2. After some quick maths, you will end up with 10, 20, 33. 33 students. All right, so part A, very, very straight to the point. As you can see over here, it's 33. See? Yeah. Then for part B, we need to write down the number of students who have not eaten at the Indian cafe. So read this carefully. See, a lot of people here would probably write down 2 immediately and keep going because they said, they have not eaten. ¿Cierto? Yeah, not eaten at either is 2, but not eaten at the Indian, for me, it's a very visually appealing solution. Think about it this way. Those that have eaten at the Indian cafe are the ones that pertain to this circle here. See? And I know you might be saying, aren't we looking for the ones that have not eaten at the Indian cafe? And I will say, true, but a lot of times in these sort of exercises with probability and stuff like that, it's a lot easier to think about it backwards. If you're trying to find all of the students who have not eaten at the Indian cafe, first find the ones that have and then subtract it from the total. So if all of these have eaten at the Indian cafe, all you have to do for part B is add up the remaining numbers. And the remaining numbers will have to be, let me just cross this out a little bit more, ¿cierto? And so the remaining numbers, all it really has to be is this 10 and this 2. So for part B, you do 10 plus 2. The numbers basically outside of the Indian cafe, 12 students. I missed an S back there. There we go. So for part B, there's the 12. Look at that. Then they tell us that a student is chosen at random from those surveyed, and for part C, we need to find the probability that this student has eaten at both the Thai cafe and the Indian cafe. So easy peasy points. We already established, but I'll do it once again because it's really important that you understand Venn diagrams, ¿cierto? This 10 is only Thai. This 8 is only Indian. This 2 is neither. And this 13 is both. Okay? So, for part C, find the probability that the student has eaten at both the Thai cafe and the Indian cafe. Well, your answer is not just 13. See? And so this is actually a cool distinction from part A and part B. For part A and part B, you need to write down each time, write down the number of, right? Write down the number of. For part C, it's probability. And so the big thing we need to understand when we're dealing with probability is that probability will always be, no matter which exercise, you guys, probability will always, 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 until you die, it will be your think about it this way, like your part divided by your whole. Okay? Another way you can understand it is that this part is like your favorable scenarios. Like if I get more fancy with this definition for probability, it's going to be like favorable scenarios. And so in this case, favorable would be like the ones that have eaten up both, divided by total scenarios. Okay, maybe that is a little more easier to understand. Probability is going to be total scenarios on the bottom, and your favorable, or the scenarios you're looking for, up top. For me, it's more intuitively to say part divided by whole. I know that for some other people, they really like the word scenarios. See? So to each their own, understand it however you want to. For part C, your favorable scenarios, or your part divided by the whole, well, your parts or your favorable scenarios are the ones that have eaten up both. And so you know that the ones that have eaten up both is 13. And you know that your total from part A is 33. And this is literally your final answer. You can leave probabilities as a fraction. Now, if you're scared to do that for whatever reason, take the 13, divide it by 33, you can leave it as a decimal. So as a decimal, it's 0.39, never ending. And if you want to leave that as a percent, you can say 39.39%. Whatever floats your boat. For part C, they are putting all of them. See? Oh, and the significant figures I forgot to mention. If you want to do significant figures, you count 1, 2, 3. Do you round it up or keep it the same? You round it up. That is how you end up with 0.394. All right, so that is for part C. And later on, we have that we need to let T be the event as student has eaten at the Thai cafe, and let I be the event as student has eaten at the Indian cafe. And so for part D, you need to find what? What is this? What's happening? Ladies and gentlemen, welcome to the world of probability. No one likes it, but you gotta do what you gotta do, right? In probability, there's a bunch of different symbols that you have to learn and associate. And right now, I will give you a quick summary of what each of these are. If you already know them, you can probably skip ahead like a minute or two. Anyways, what you will be facing in the world of IBAISL are these symbols. You're going to have the symbols, this one. You're going to have the symbols of this one. And you're going to have the symbols of this one. Okay? So, intuitively, this first one, it looks a little bit like what? It looks a little bit like an N. And so this first one is technically, okay, the probability of drawing X and Y. So this one is much easier to memorize, for me at least, because the symbol that it has literally looks a little bit like an N. See? And so that reminds me that we're talking about and. Okay? Yeah, so that's the probability of landing X and Y. This one down here, well, what's not the opposite, but maybe it is the opposite, I'm not sure. You have and you also have or. So this symbol here is going to be for or, okay? I don't have a friendly way to remember that besides the O being very similar to the U, okay? To each their own, that's what this symbol means, see? And last but not least, this one is the probability of X given Y. So all of these are probability of X and Y. Then here we have probability of X or Y. And last but not least, we have probability of X given Y. And the biggest observation I can do here is that each of these symbols, for example, this N, should remind you of the word and. This symbol here should remind you of the word or, and this symbol here should remind you of the word given. If you are more of a visual learner type of person, here's a quick Venn diagram that might help you. So if this is X and this is Y, let me draw one for each, okay? Yeah. So if I draw one for each, the probability of X and Y is going to be the intersection of both. So it's going to be right there. And the probability of X or Y is going to be the basically like the combination of both. See? So that would be x or y. And last but not least, this is the weirdest one. X given y is basically like you're within x, but you're drawing, sorry, x given y is that you're within y and you're drawing x. And you might be thinking, is it that the same as the first scenario? And the small difference that I'm about to point out now is the following. For the one up top, your total scenarios, notice, your total scenarios for the one up top is everything. Your total scenarios is quite literally everything. See? It's just that you end up drawing the intersection. Your total scenarios for this next one, for the OR, is also everything. Your total scenarios is still everything. But the total scenarios of x given y means that you're only in the playing field of y and you end up drawing x. And so the big hint for given probability is that it changes your total. You can also think about it like it changes your denominator. See, it changes your total scenarios. But that is the main things you will be facing in AISL. And so if we come back to reality just for a second, this symbol, which one was it? Or. So we're talking about the probability, because there's a P here, the probability of T or I. Now the probability of T is the probability of a student eating at the Thai cafe, and the probability of I is the probability of a student eating at the Indian cafe. ¿Cierto? So if we're talking about T or I, we're talking about this scenario here. As you can see, technically we're filling in all of this. ¿Cierto? Ba, 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 ba. And so your favorable scenarios in this case is going to be everything that's inside, 10 plus 13 plus 8, while the total scenarios, it's like the whole box. ¿Cierto? So the total scenarios is going to be everything on the outside, and also everything on the inside, ¿cierto? And so, so your total scenarios are going to be 10 plus 13 plus 8 plus 2. So look at that. Doesn't it look pretty? Favorable scenarios is T or I, so it's going to be everything inside the circles, basically. And your total scenarios is still the two circles, the intersection, and the 2 that's right outside. So that's a small difference that we have to face. So for this part, you can go ahead, open up the fraction once again because it's much easier, and you also feel very fancy putting in a fraction, let's be honest. And go ahead and add it all together, see what happens. Bada bim, bada boom, there it is. 31 divided by 33. 31 divided by 33. I'm not going to show the decimal places stuff because I did for part C, but just so you trust me, there it is. See? Yeah, so that is for part D. And last but not least, for part E, we have the fancy state whether the events T and I are, ooh, look at that, mutually exclusive. Justify your answer. So, what does it mean for something to be mutually exclusive? Mutually exclusive is a little bit like monogamy. Okay, you are only with your partner and nobody else. And so if two things are mutually exclusive, that means you either are a student that only eats at the Thai cafe, or you're a student that only eats at the Indian cafe. Now, obviously, you look up here and you're thinking, I mean, there's people that eat at both. So that's already an argument for saying that the events T and I are not mutually exclusive. And so the other observation it can sort of show you is that if they were mutually exclusive, and this is something that I feel like not a lot of teachers show, but I think visually can help a lot because there are a lot of visual learners out there. If they were mutually exclusive, your Venn diagram would look like this. Here's your Thai, and here's your Indian. So notice how Thai and Indian don't even have an intersection. And why do they not even have an intersection? Because they are mutually exclusive. It is one or the other, but not both. That's probably the best way I can put it, actually. One or the other. That was lovely. One or the other, but not both. So if you want to remember this in a more intuitive way, there you go. One or the other, but not both. And so clearly for part E, you can write that out. You can literally write out like, there's students that ate at both. Como que duh, ¿cierto? And literally, that will give you a point. Look at this. Except an equivalent statement words such as, certain amount of students went to both cafes, or students can simply just go to both cafes, you know? And so and after saying that, your conclusion is no, they are not mutually exclusive, okay? So that is one way to answer. And you are also observing all these fancy sort of formulas going all around it, see? And so another way you can solve this, okay, in case it makes you feel a little bit more comfortable, or just to add a tool to your toolkit, is that the moment that you read the words mutually exclusive, you should immediately be thinking, bada bim, bada boom, formula booklet. Now, not a lot of people do this because they're not familiar with the formula booklet. But I've done like 1 million YouTube videos and I'm pretty familiar with it. And ideally, the level that you reach, okay, as a student, is that you identify these sort of buzzwords, these key concepts, and you recognize them as things that are in your formula booklet. And I'm not saying that you read mutually exclusive and you remember the formula for mutually exclusive probability, but you should be able to recognize the words as something familiar and say, that's probably my formula booklet, okay? So that is what I mean by remembering these sort of buzzwords and stuff like that. Because the day of tomorrow, you might be solving an exercise that says, find the interquartile range, and you have no idea what it is, but it sounds familiar. And so you go to your formula booklet and you solve it easily, ¿cierto? Or maybe, I don't know, whatever, it's like, you're trying to find the area of a triangle, you can't solve it with what you have, but you know that within your formula booklet, you actually have 2 equations for area of a triangle. You have the trig one, and you have the classic one, which is way up here. And so it's that sort of small itty bitty details that can really save you the day of the test. Get familiar with the formula booklet. It's gonna save you. It saved me, okay? Back in the day, a long time ago. So that being said, eventually you can read mutually exclusive, you can recognize this as the formula booklet, and you will find it right here. So basically what's happening is that if they are mutually exclusive, then this has to be true. If they're mutually exclusive, then this has to be true. So notice, the probability of A or B has to equal the probability of A plus B. Now, if I apply that over here, ¿cierto? So right now they're asking for the probability of T or I, ¿cierto? So if they're mutually exclusive, then the probability of T has to equal, if they're mutually exclusive, the probability of T or I has to equal the probability of T plus the probability of I. But if I go ahead and try that, what you're actually going to encounter, ¿cierto? Is that the probability of T is all of this, ¿cierto? It's all of this. And so for a probability of T, you end up with 10 plus 13 divided by your total, which is 33, found from part A, ¿cierto? And for the probability of I, which is over here in green, you're going to see that you're doing 13 plus 8 divided by 33. And what's the big mistake that's happening here? The big mistake that's happening here is that this 13, you're adding it twice. Quite literally, it's here and it's here. And so what you're supposed to do when there's an intersection, which is what they do over here actually, is that you get rid of that intersection at least once, so that you don't end up adding 13 twice, you get rid of it at least once. So if they were mutually exclusive, this wouldn't be a problem. But here it is, ¿cierto? So, probability of T or I, we found it from part D, which is 31 divided by 33, right? But if you actually try to add these two together and see what happens, you end up with 31 divided by 33, supposedly equaling 23 divided by 33 plus 21 divided by 33. So you end up with 31 divided by 33, supposedly equaling 44 divided by 33. Now you guys, 31 divided by 33, does it equal 44 divided by 33? No, it does not. See? And so because it does not, then since this statement was not true, they are not mutually exclusive. So your argument in this case is basically saying this right here, ¿cierto? So, which comes from this, ¿cierto? So because you ended up writing this out there, it's the same as saying this out here, ¿cierto? And if you're saying this out here, then you're saying that they're not mutually exclusive. Okay, so that is just one more way to sort of find the answer. Whatever floats your boat. I'm just here to show you the tools. You are here to learn how you learn and how you understand things better. See? So whatever floats your boat, stick to it. That is for number 2, and I hope it helped.